So now we're supposed to be figuring out the equation and the graph of an inverse. So the first thing they do is give us the original function. It's a pretty simple one, y equals x squared plus 3. And I know they're going to ask me to graph it, so I'm just going to go ahead and do that before I even do anything else because it's so simple. X squared is just a parabola. It would go over 1, up 1 because 1 squared is 1. It would go over 2, up 4 because 2 squared is 4, and so on. And I know that it's going to be the same on both sides because you can't have a negative square. So I also know from my last chapter that if I have a plus 3, that means it goes up 3. So my first point is going to be at 3 on the x-axis, or y-axis, sorry. And my point is going to be up 1 over 1 here and here, and then up 2 over 1, 2, 3, 4, here and here. So it doesn't even really matter where my starting point is. I can still sketch that same shape that goes over 1, up 1, over 2, up 4. All right, now I know that I'm going to want to flip it over the y equals x axis. So if this were my line, then I want to flip it over there. And if this were wet ink and I folded the page, that means this is going to be down here. So I can use that logic to go, okay, this is 0 and 3, so I'm going to make this one 3 and 0. These other ones then are going to continue the pattern from there, sorry, and I'm going to have a graph that looks something like that, and it's that way. So I've got the graphing done. That part was easy. But if I wanted to actually use the equation, it's not so easy to look at that and make an equation. It's not exactly y equals mx plus b. So what I do is I go back to this original and I switch my x and y. So x becomes y squared plus 3. But if you look at your graphing calculator, they don't give us an option for x equals. It's only y equals. So I have to change this algebraically to equal y. So I'm going to make my negative 3 come over to this side. So x minus 3 equals y squared. How do you get rid of a squared? You take the square root. So I'm going to take the square root of this one. That's going to knock that out. What it ends up looking like is this. So that means this graph is y equals the square root of x minus 3. Now you can check this in your graphing calculator, but you have to be a little bit sneaky. Because what you're going to find out is that when you punch it into your calculator, well, I'll show you. So here I have written in my calculator x squared plus 3 for the top one, and the square root, we'll pause, the square root of x minus 3 on the bottom. But if I hit graph, this is what happens. What happened to the bottom side of this graph? Is it just not there? Well, no, but it didn't give you the positive or negative square root. So what you have to do is actually make it a negative second function, x minus 3, like that. So I put the negative on the outside. It will only do the positive one by default, so you have to actually do the negative one separately if you want to get the rest of the graph. Yay! Now it's an inverse relation. Now let's see if your book wanted anything else. Oh, last one, and this is leading up to something different in a second, so pay attention. Is this a function? No. No, it isn't. It's not a function because this one's a function. Yep, only one, ting, 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 only one. Even though my graph looks like it kind of doubles back, it keeps going out, and there's only one value of x for every value of y. However, this one, right away, violates. Nope, not a function because it's flipped on its side. There's two values of x for every value of y. So, it's not a function, even though the original one was.